You know, have you ever really stopped to think about the invisible science that keeps you safe inside a building? It's something we totally take for granted, right? But it's this incredibly detailed system designed to protect us from one of our oldest fears, fire. So let's get into it and figure out how our homes are actually built to survive.
So, the big question is what really makes a building fire safe? It's definitely not magic, and it's not about making them completely fireproof either. That's pretty much impossible. The real answer is a little more complex, and honestly, it's way more interesting. It's all about a calculated strategy.
And that whole strategy, it's all about buying time. See, the goal isn't to stop fires from ever happening or to make buildings indestructible. The real point is to make sure that if a fire does break out, the building itself can fight back for a very specific amount of time. This gives everyone inside that crucial window to escape, and it gives the fire a chance to burn out before the whole structure comes down. And that leads us right into the core idea behind all of this, fire resistance. Now, this isn't just some vague term. It's a measurable, testable, and absolutely critical quality that forms the foundation of every single fire safety rule out there.
Yeah, it all boils down to these three letters R, E, and I. Each one stands for a different job that a part of a building, like a wall, a floor, or a door, has to do when it's literally under fire. First up, we've got R for load-bearing capacity, or you can just think of it as stability. This is the absolute basics. It's about whether a wall or a beam can keep holding up its own weight, plus the weight of everything above it, without collapsing when things get incredibly hot. Next is E for integrity. Think of this like a shield. It's the ability of a wall or a door to stop the actual flames and all those super hot toxic gases from punching a hole through to the other side. If you lose integrity, the fire spreads. And that's when things get really dangerous. And finally, I for insulation. Now, this one's pretty clever because even if a wall has perfect integrity and no flames get through, it can still get so hot on the safe side that it sets fire to furniture or carpets just through pure heat. Insulation stops that. It limits how hot the other side can get, preventing the fire from spreading invisibly. And this image here just pulls it all together perfectly. You've got stability on the left, which is keeping the structure standing. You've got integrity in the middle, stopping flames from sneaking through any cracks. And then insulation on the right, blocking that intense heat. Stability, integrity, insulation. R-E-I. That's it. That's the building's shield. But you might be asking, how do we actually know this stuff will work? Well, they don't just guess. They test it. And I mean, they really test it. They stick building parts inside these gigantic furnaces and blast them. As you can see, walls and doors get tested vertically, while floors and ceilings get tested horizontally, mimicking a real fire. And just look at this. This is a successful test right here. That fire door is doing exactly what it's supposed to do. It's holding back that inferno, maintaining its integrity. This is where all that science proves itself in the real world, showing that this stuff actually works. Okay, so we've got the science of REI down, but how does that science turn into the actual rules for building the house or the apartment you live in? Well, in England, it all comes down to one really important document. Let's take a look at the official rulebook. It's called Approved Document B. You can basically think of it as the instruction manual for every architect and builder in the country. It gives them the practical, step-by-step guidance on how to apply all that fire science we just talked about to meet the legal safety requirements. And the whole document is broken down into 5 main goals. B1 is all about warning you and giving you a clear path to escape. B2 and B3 are focused on stopping the fire from spreading inside the building. B4 is about making sure the fire doesn't jump to the building next door. And finally, B5 ensures that when the firefighters arrive, they can actually get in and do their job.
But here's the thing. You can't just write these rules once and call it a day. A rulebook that's set in stone can be a very dangerous thing because fire safety is something we're always learning more about. So the rules have to change and adapt. Let's see how that actually works. This timeline really shows that evolution in action. For instance, in 2020, they lowered the height where sprinklers become mandatory. In 2022, they tightened the rules on what materials can be used on the outside of buildings. And looking forward, new, taller buildings will soon need a second staircase. The key takeaway here is that the system is designed to learn from the past to make the future safer.
All right, this is where it all comes together. We've got the science, we've got the rules, and we know the rules are always improving. So how does all of that come together to decide exactly how much fire protection a specific building needs? Well, it really boils down to two simple things. How tall the building is, because obviously the higher you are, the longer it takes to get out, and what the building is used for. A hospital is going to have way different risks than an office or an apartment building.
And check out the difference this makes. It is huge. For a low-rise apartment, the structure might only need to provide 30 minutes of fire resistance. But you take that up to a high-rise, over 30 meters, that requirement jumps all the way up to 120 minutes, 2 hours. It makes sense, right? More risk means you have to buy a lot more time.
So where do these numbers come from? They come from a master chart, like this one, called Table B2. Now, I know it just looks like a grid of numbers, but this thing is basically the recipe book for fire safety. An engineer looks at the building's height and its purpose, finds the right box on this chart, and that tells them exactly how many minutes of fire resistance they need to design for. So when you put it all together, the REE science, the official rulebook, all the brutal testing, and the constant updates, you realize there's a really sophisticated plan for dealing with fire. It's a whole system designed from the ground up to manage risk and give us all the time we need to get to safety. So it's clear the rules are always getting better and our buildings are getting safer. But that does leave us with a pretty big question. As we build even higher, start using brand new materials, and face different challenges, what's the next big frontier that our rules for survival will have to conquer?